Hey guys, it's Mr. Sheeline here again. I'm going to be giving you guys another video that'll basically just be me walking through how to balance out two equations. One that's a little easier and then one that's a little bit more challenging. So let's just get straight to it. Okay, so again, remember this is in real time. I haven't pre-solved these. I'm solving these as I'm recording, so you get to kind of see what it looks like that I'm doing in real time, raw, and sure, whatever other words you want to associate here. Okay, so looking at my problem here are my reactants, here are my products. So I'm going to go straight to making my T-chart. So number of atoms on the reactant side split by yield sign, and then my number of atoms on my product side. So we're not working with too many. It looks like we're working with just 4. So we've got silicon, we've got chlorine, we've got hydrogen, and we've got oxygen. Okay, now let's just count them out. So on the reactant side, it looks like we've got 1 for silicon, we've got 4 for chlorine, 2 for hydrogen, 1 for oxygen. And then over here on the product side, we've got 1 for silicon, 2 for oxygen, 1 for hydrogen, and 1 for chlorine. So this guy is, interesting. Just interesting just because I think I can already start seeing what I've got to do here. But let's just walk through. So silicon, it looks like I really can't do anything with that. Chlorine, need to get this guy from 1 to 4. Hydrogen needs to go from 1 to 2, and then oxygen over here needs to be 2. Okay, and then just to double check, it looks like this is nothing but a classic. Yeah, we've got a double replacement reaction here, which it's possible that we haven't covered that yet, but meaning all it means is that basically chlorine and oxygen swap places. So, but looking at this, and it's important just because I'm looking at this and I'm seeing that over here, silicon and oxygen are no other places, hydrogen and chlorine are in no other places. Over here, yeah, same thing. Silicon and chlorine just over here, hydrogen and oxygen just right there. So we can start with whoever we want, but let's see. So silicon we can't really start with. We could start with chlorine if we wanted to. Hydrogen, it really doesn't matter. We could start with any of them. Let's just start with chlorine because it's there at the top. So I'm going to change my chlorine here. I'm going to change this guy to a 4. Okay, just because I want to get chlorine to 4. So let's go change that to 4. But now I've got 4 hydrogen on this side as well. So silicon's good, chlorine's good. Let's just keep working our way down. Let's see, hydrogen. I've got to change this guy from a 2 to a 4. So looking over here, it looks like I've got H2. Stick a 2 in there. And then that's going to change that from a 2 to a 4. But it's also going to change my oxygen to a 1 to a 2. And that solves the whole thing. So that's pretty much what I figured was going to happen. I kind of saw that unfolding itself, so pretty easy. So my full balance equation is going to be silicon, it's going to be silicon tetrachloride, and just 1 molecule of that, and then 2 molecules of water, of H2O, and then I'm going to have just 1 formula. Oh, sorry for this. There's 1 formula unit here of silicon oxide, and then 4 formula units of hydrochloric acid. And that's it. So this guy's all nice and solved. So let's now move on to something a little bit more challenging. Okay, so we've got this big old boy. So we've got C5H8O2 reacts with NaH, and that reacts with, again, hydrochloric acid to produce C5H12O2 and then sodium chloride. So let's just solve this guy out. So this guy's going to be pretty busy, and I'm going to make sure to leave a lot of space because we might be doing a number of crossing out here and mix matching and seeing what works and what doesn't. Okay, so lots of space. Here's my T-chart, and let's just see what we're working with. So we've got carbon, hydrogen, oxygen, sodium, and chlorine. Okay, so just this is where we got to be careful with numbering because you can see here hydrogen is in 3 locations. So let's just be careful with that and keep a note of that. So it looks like we've got 5 carbon. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogen. We just have 2 oxygen. We only have 1 sodium and 1 chlorine. And over here, it looks like for carbon, we've got just 5. Still, looks like now we got 12 for hydrogen. We've got 2 for oxygen still. We've got 1 for sodium and then 1 for chlorine. Ooh, so this guy's going to be kind of a challenge. Excuse me. So this guy's going to be kind of tricky. And I only say that because if you notice, look at this. So we've got 5 to 5, 2 to 2, 1 to 1, 1 to 1. And it's only this hydrogen that's kind of messing things up here. And not only that, we've got 3 locations of where we can change our hydrogen. So it's going to be interesting. Okay, it's going to be, to say the least, it's going to be interesting. So let's just start plugging things in to see what happens. Okay, so again, the only thing that we can work with is the hydrogen right now. That's literally the only thing we can work with because again, everything else is set equal to one another. The ratio is equal except for hydrogen. So I don't know. So I'm looking at this, looking on product side, or sorry, reactant side here, and I'm seeing there's 8 here. Maybe this guy isn't messed with because I don't know if I want to. If I put a 2 here, that's going to change that to 10. That's going to change that to 4, and that's going to change that to 16. And then I'll have instead of having 10 over here, I would then have 18. And I don't know if I really want to mess with that, especially if there's 12 over here. If I put a 2 there, it's going to be 24. So maybe I leave this guy alone. So it's more or less just split between these 2. So here's my thought process, is that, okay, if I've got to choose between these 2, who do I want to mess with? And arguably, just looking at it, it looks like, well, hydrogen's here, hydrogen's there, yes. Sodium's here, chlorine's here, and there's sodium chlorine over here, but there's no hydrogen. So maybe this isn't so bad after all, and here's why. So maybe it doesn't really matter who I start with. So let's just toss a 2 here and just see what happens. So I'm going to toss a 2 here. So now I've got 8, and then there's 2. So now I've got 10 and then 11. So that's going to change that to 11, and now that changes my chlorine over here to 2. Okay. And then I don't know. We're still, and I'm still focusing on hydrogen here. We're not going to worry about this just yet. But I'm not there yet. I'm still 1 behind. I don't have 12. So again, I'm not going to mess with this guy. Let's just add a 2 over here. So let's see here. So that's 8. And then that's going to factor in over here. That's going to be 2, and then another 2. So 8 plus 2 plus 2 is 12. So now I've got 12 on this side. But I've changed my number of sodium to now 2. And it looks like here I've got 2 to 1, 2 to 1. And this is why I said maybe it's not going to be as bad as we figured. Because seeing that I need 2 of sodium over here and I need 2 chlorine over here, I'm going to look on my product side and say, oh, they're right there. All I got to do is that. And then that changes that to 2, and then that changes that to 2. And then we double check, 5 to 5, 12 to 12, 2 to 2, 2 to 2, and 2 to 2. And I've got a balanced equation, and then I would rewrite it as C5H8O2 reacts with 2 NaH plus 2 hydrochloric acid yields just 1 molecule of the C5H12O2 and then 2 formula units of sodium chloride. And I would have my full balanced equation all ready to go. Okay? So again, I hope this video helps you guys out. I hope you can kind of see what it is that I'm thinking while I'm doing this, what I'm looking for, and what it is that I'm trying, what I do in real time. Again, hopefully this helps you, and hopefully you're starting to see that this is, it's basically just a puzzle. That's all it is. It's I guess that's the best way I describe it, is it's just a puzzle. So if you still have any questions, though, make sure you ask me. Again, I hope this helps you out. See the other video or videos that I have posted concerning, balancing equations out. Oh, and maybe if you find a really tricky one, maybe email it to me. And like if you can't figure one out, if you find one and you can't figure it out, send it to me, and I'll see if I can solve it. Because again, I love doing this. This is a lot of fun. It's just a puzzle for the most part. So anyway, all right, thanks guys, and I'll see you in the next one.